10, 9, 8, 7, 6, 5. Vehicles armed. 3, 2, 1. Fire. Missile away. +5. +10. Burn out. Good burn. Copy, good burn.
The only way right now for humans to travel to space is through rockets. But what if I told you there was another way, a much more cheaper and efficient route? And the answer is a space elevator. While it would seem as the elevator like the one in the Charlie in the Chocolate Factory, which with the press of a button can whoosh us into space, the reality sadly is that it's not that simple in its workings, but it is in fact possible. A space elevator may seem a piece of science fiction from Star Wars, but with recent breakthroughs and developments, a space elevator can become a reality. But let's first address the question, what is a space elevator? For that, we need to go back 125 years, when Russian scientist Konstantin Tsiolkovsky, being inspired by the Eiffel Tower in 1895, ideated about a similar tower that reached all the way from the ground to the void of space. But there was a problem with this. As the Earth rotates eastward in prograde motion, then the question arises, how can we keep the elevator stable? And to do that, we have to make the elevator go up to 35,786 kilometers, where it will lie in the geostationary orbit, and make sure that all the forces cancel each other out. The main purposes of a space elevator is to make space travel more routine and much more cheaper. According to SpaceX, it takes roughly $2,700 to spend 1 kilogram of weight into low Earth orbit, but with a space elevator, it is estimated that it would take no more than $200 to get 1 kilogram of weight into space. The main structure of the space elevator would consist of a long tether between a geostationary satellite and an anchor point somewhere on the Earth's equator. A climber would ride along the cable to take cargo and even humans into space. Simple, right? Only it isn't. There are many challenges which combat our theory, which we have to solve in order to make this a reality. But if we can solve these problems, will a space elevator really be possible? And today we are going to find that out, as we will be designing a space elevator. So let's begin. With the development of a space elevator, we need to solve some challenges that come up with this theory. First one being, how can we get the fuel or energy to get the climber go up the tether, and for that, we have one option, a free electron laser system which would power a climber located on or near the anchor station. The laser will beam 2.4 megawatts of energy to photovoltaic cells, perhaps made of gallium arsenide attached to the lifter, which will then convert that energy to electricity to be used by conventional niobium magnet DC electric motors. Now, since we have solved how the climber will be powered, another problem that arises is how are we going to avoid space debris? Like the space station or space shuttle, the space elevator will need the ability to avoid orbital objects like debris and satellites. And to solve that, the anchor platform will employ active avoidance to protect the space elevator from such objects. Currently, the North American Aerospace Defense Command tracks objects larger than 10 cm. Protecting the space elevator would require an orbital debris tracking system that could detect objects approximately 1 cm in size. This technology is currently in development for other space projects. Finally, we are tasked with one more question to solve, which is the tether itself. The tether needs to be much more stronger and elastic than any material known to us. Also, the tether has to be the most thickest at the geosynchronous altitude, as it will face the most tension at that point. I researched about various items that could fit this demographic, and one name popped up. Carbon nanotubes, which have the potential to be 100 times stronger than steel and are as flexible as plastic, which can be a good material for the tether, but one limitation comes with it. The mass production of carbon nanotubes for now is a distant dream, as scientists are still figuring out a way to mass produce them. So we come to the conclusion, is a working space elevator really possible? And the answer is yes. While it will take time for us to construct it and make it a reality, we are not very far from it. with companies such as Obayashi Corporation, a global construction firm based in Tokyo, which are set to construct a space elevator by 2050 and are conducting small-scale tests to prove the concept of such a transportation device. While we are a little far away from this dream, but when it will be made, it will be the holy grail of science exploration.